You can achieve a flow state by letting go, reducing anxiety, letting go, taking a chance on doing things.
That was Professor John Kounios of Drexel University. Today, we're going to dive into the neuroscience of the aha moment, the Eureka effect. He's one of the world's leading experts on insight and creative breakthroughs. We're going to explore why ideas strike suddenly, what's happening in the brain during an insight, and how you can increase the chances of having more insights in your own life. If you like this episode, please consider sharing it with someone like you who's interested in creativity. Rate the show or leave a comment. It really helps. Now, here's our interview. I'm here with John Kounios. Thank you so much, John, for joining me today.
Oh, thanks for inviting me.
Well, John, you're a senior figure in the field of creativity research, and you've done so much work over the decades. You know, we could fill 3 or 4 or 10 podcast episodes. There's a lot I want to ask about, but I wanted to start with this concept of the Eureka effect, because that's the name of your book. What is the Eureka effect?
The Eureka effect is pretty much the same thing as the aha moment. It goes by other names, sudden realization. It's when a person has a new idea, a new perspective, a new way of looking at things, a solution to a problem, but it comes to them suddenly, unexpectedly, sometimes seemingly from nowhere. It could come while you're working on a problem, but it could also come while you're taking a shower. It could come to you in your sleep, either in a dream, or it could wake you up from sleep. So it's any sudden, abrupt realization or solution to a problem or idea that is novel to that person.
It sounds like the moment of insight. Is that right?
Yes, that's actually the name. Insight is the name that experimental psychologists have applied to that phenomenon for, 100 years, going back to the days of the Gestalt psychologists in Germany around the time of World War I. That was the original term. That's the term still used by psychological scientists and increasingly neuroscientists. But in the vernacular, people talk about aha moments, although the term aha moment has a broader meaning in the popular culture. Often people use the term aha moment to refer to any kind of deep realization. And that's not exactly what psychological scientists mean. It has to be something that's sudden, that it just pops into awareness to be a true insight, or an aha moment, as psychological scientists sometimes call it.
The aha moment, Eureka moment, insight. What is it that's different about this moment of insight as opposed to, everyday thinking? Like we go all day long without having sudden moments of insight. So what's different about it?
Well, that's an interesting question, because often people have these sudden insights and they don't even realize that they've had them. So some insights, some aha moments kind of, smack you in the face. They hit you right between the eyes because it's just a radically different way of looking at things that solves some pressing problem or provides some new opportunity. But often we have little insights that might just, solve some everyday problem, like how do you get your toddler to eat vegetables or something like that. And it doesn't make a big impression. So a lot of the ideas we have during the day are insights, but we don't note them as such. We don't trace them back. It's sort of like, you go to the doctor and you complain about some pain or something, and the doctor says, well, when did you first have this pain? And you didn't make a mental note of that because when it started, it wasn't a prominent thing in your awareness, right? So it's similar to this. Sometimes these insights are powerful, emotionally powerful, and powerful in terms of the opportunities they provide, but sometimes there's not a great deal of emotion associated with it, and the problem it solves might be very minor, so we don't always notice them. But people have them during the day. I'd say the vast majority of people, whether they're aware that they have them or not, do. Now, there may be some individuals who just don't think that way. But in the experiments that we've run and we've tested, I don't know, I'll guess perhaps 1,000 people, maybe maybe much more than that, maybe 1,500 people over the years. And I'd say 99.9% of them in our experiments do generate some insights, some aha moments. And it's very rare that people don't know what we're talking about when we mention these insights and that they don't report having them.
Oh, did you say that you actually have people having these insights in the laboratory while you're doing the research?
Yes. So we measure psychological processes and also brain processes associated with having insights in controlled laboratory conditions. And that's how we are able to identify the neural correlates, the brain processes that are associated with having these insights.
That sounds like some really powerful research. If you can cause people to have these insights right there, I don't know if on command is the right word, but how do you do that? How can you be sure of having someone have one of these insights while you're there watching them?
Okay, well, nobody can generate an insight on command. We certainly can't command people to do it.
Right.
Insights are sort of like cats. You can coax them, but you can't order a cat to do anything. So we create conditions under which people are more or less likely to have insights. In most of our experiments on insight, we've given people little verbal puzzles. Some of them are anagrams where people have to unscramble letters to find a word, or another kind are called compound remote associates, where we give people 3 words and they have to think of a 4th word that combines with each of those words to form a familiar compound or phrase. So for example, let's see, what would it be? Pine, crab, and sauce. And the solution to that is apple, pineapple, crab apple, applesauce. So we give people many of these little puzzles. And those kinds of puzzles are the kinds that people can solve in one of 2 ways. You can solve it by consciously and deliberately working your way through it. And we call this, we're not the only ones who call this, type 2 or system 2 thinking. And that's conscious, deliberate manipulation of the elements of the problem or the hypothesis testing. So if you have pine crab sauce, you might think, what goes with pine? Well, tree goes with pine. Does tree go with crab? Well, crab tree. Does it go with sauce? No, I'll try another solution. And same with anagrams. You could try manipulating the letters to find the word consciously and deliberately. Or sometimes you hear or see the problem and the solution just pops into awareness as an insight. So when people solve these puzzles, we simply ask them afterwards, did that pop into your awareness as an aha moment, or did it result from your working it out in a conscious, deliberate way? And people are very good about this. This kind of technique is a similar technique is also used in memory research, where you ask people if they can remember something. Do you ask them, do you consciously remember when you acquired this piece of information? Or do you just know that you saw it before? So we use that to measure brain processes, to see what kinds of psychological variables will increase the likelihood of having insights or of solving puzzles analytically. And sometimes, in a particular study, a person might sit down and solve 60, 70, 80, 100, 120 of these things, as many as we can get them to do before they start to protest. And they might solve half of them. And of that half, maybe a half of them they label as resulting from insight, and half of them resulting from what we call analysis, that conscious, deliberate thought process that can grind through in a step-by-step way to come up with a solution to a problem.
I'm familiar with that research paradigm, the remote associations, and you contrast that. So if we give someone 3 words, we say red, green, and blue, then you're going to say color. And there's no insight there, right? It just comes right up. But that's
easy. Right.
You create 3 words that the 4th word is not obvious, right?
Yes. So what makes these a measure of a type of creativity is that for at least one, if not all three words, the solution is not a strong association. So, when you hear the word pine, maybe the first word that comes to your mind is tree or cone. It's not apple, right? So you have to come up with the non-obvious, weak association to one or all three of the words in order to find the solution. And that's sort of the one aspect of the essence of creativity is that creativity is something that allows you to find an idea or a solution or a perspective that's not obvious. If it were obvious, we wouldn't call it creative and people would be doing it all the time. So it has to be non-obvious, not just difficult, because doing some kind of complicated arithmetic problem could be difficult, but it's not non-obvious. I mean, we learned in elementary school, hopefully, how to do arithmetic. So it just may take a lot of steps and you have to be careful and not make mistakes, but it's not non-obvious.
Right. So, okay. So let's see, you get these three words and it's not obvious right at first. And then you have a subjective sensation of insight. You just say, oh, now I get it. It's apple. So you said people are really good at telling you if they have this sensation or not. So what's going on there? What is it? I think you've done some brain imaging research where you can actually tell where in the brain someone's having that insight.
Yes. So in our studies, well, in the initial study, we found that we used both EEG, electroencephalography, and functional MRI to localize not only where in the brain is the brain areas that are associated with this sudden insight, but also when it occurs. So you need both techniques. So EEG, electroencephalography, measures brain waves, and it's really good at telling you when something's happening in the brain. And it's not as good at telling you where something's happening in the brain. It gives you some decent spatial information, but that's not the specialty of that technique. The specialty is the timing. It tells you when. Functional MRI is great at telling you where something's happening in the brain, and it's not as good at telling you when something's happening in the brain. So by using both techniques, we're able to localize in the brain, both in space and time, the brain activity associated with this aha moment. So without the EEG, you could have some activation in the brain that you measure with functional MRI, and you won't know if that's really the aha moment because maybe that brain activation, that part of the brain turning on, maybe it's coming before the actual aha moment, or maybe it's coming after the aha moment. You need the EEG to set the timing. And similarly, with just EEG, we would get an idea of, roughly where it's happening in the brain. But we get that, we need the fMRI, the functional MRI, to give a precise readout of where it's happening in the brain. The EEG tells us when. So we can localize, using the two techniques, we can localize this in space and time as well. And in our first study, which was published more than 20 years ago now, 21 years ago, we found for those three-word problems, the compound remote associates, that there was an area in the right temporal lobe, just above the right ear, that suddenly increases activation at about the time when the person is experiencing this aha moment, when the solution to the problem is popping into awareness. At first we thought, this is sort of the insight area of the brain. However, subsequent studies show that the part of the brain or parts of the brain that are associated with having the aha moment depend on the type of problem. So for anagrams, we don't see that area above the right ear. We see areas in the extreme front of the brain and in the left hemisphere. But the thing that seems to identify an aha moment is not so much where in the brain, but the suddenness of this brain activation. So it's high frequency, high energy brain waves that just pop all of a sudden. And that pop can occur in different places for different types of problems. But that characteristic pop is the signature of the aha moment in the brain.
Something I've always wondered about when I hear about this research is, what are the practical implications? So I'm trying to be more creative and you tell me it's above my right ear. What can I do with that?
Well, what you shouldn't do is like hit yourself on the right side of your head. That's not going
Right.
to help. Okay, right? We know that's not going to help. And some people like to slap their foreheads. That's not going to help either. Okay?
Right.
So the practical benefit of this research is that it identifies that there are these at least two distinct ways of having an idea. And actually, I would argue what we'll talk about later with improvisation, there's a third way as well. But there are at least two distinct ways of generating these creative ideas, these non-obvious ideas. And once you realize that there are two distinct brain mechanisms for doing that, you can see, all right, do the same factors, the same variables, the same manipulations help both? Or so, for example, one of the most prominent ways to increase the likelihood of having an aha moment is by putting a person in a positive mood. Positive mood changes a lot of aspects of brain function. It expands the scope of thought, expands attention, makes your thinking a little bit fuzzy, but it by expanding the scope of thought, it allows these non-obvious ideas to pop into awareness. On the other hand, if you are a little bit anxious, then it focuses thought, it makes it more goal-directed, and it promotes this analytical, step-by-step conscious thinking. So obviously, these are different ways to have ideas. And so you shouldn't necessarily think that one manipulation is going to improve all kinds of creativity, because there are different types of creativity. You could come up with creative ideas through this step-by-step analytical, deliberate kind of process, and you can come up with creative, non-obvious ideas through an aha moment. But you don't get to those two types of, you don't have those two processes or promote them in the same way. So one, I guess, sort of little parable one could tell, courtesy of my colleague and collaborator Mark Beeman at Northwestern University, is the idea, if you can imagine an early human on the savannah in Africa, and that person sees way off in the distance a lion. Well, what does that person do? Immediately, the lion, it just grabs their attention. And you very consciously and deliberately, you're afraid, right? So you have anxiety. The person consciously and deliberately thinks, okay, how far away is that lion? Can the lion see me? Can the lion hear me? Am I upwind or downwind of the lion? If I run for that tree or that cave, would the lion see me and be able to catch me? You go through all of these conscious calculations because the anxiety narrows the scope of thought, it narrows attention, and it makes your thinking very deliberate because you cannot afford to make a mistake. If you make a mistake, you're lunch for the lion. Now, you get away. Thank goodness you get away from the lion. That evening, you're in a nice safe cave with your clan. There's an antelope on the rack roasting on the fire. There's plenty of food. It's warm in the cave. The cave is safe from predators. You're with your trusted clan members and family. And anxiety, the sense of threat is low. You have a sense of what's called psychological safety. That positive mood expands the scope of thought. It allows in remote associations, non-obvious ideas. And that's okay. You can express or at least think some crazy thoughts because there's no downside. There's no threat. You're not going to become lunch for thinking some irrelevant, crazy thought. And some of those irrelevant, crazy, remote associations are going to be creative. They might be even useful, ways to help a person or the tribe survive better and thrive. So that positive mood, that sense of psychological safety enhances one type of creativity, insight, and it actually depresses analytical thought, which is enhanced by anxiety, which focuses attention and narrows it. So that's an example there of how knowing that there are these two different ways of generating ideas, how that gives us the opening to go in there and say, all right, how do we improve one? How do we improve the other? Sometimes by improving one, you're hurting the other. Insights are generally pretty good at solving really kinds of, to come up with really so-called outside the box kinds of solutions to things. Even better, they often provide solutions to problems you didn't even know you had. So in analytical thinking, this is what we call type 2 or system 2 thinking, the conscious deliberate thinking. Usually you have a problem, you identify it as a problem or a goal, and you work on it consciously. But insights can provide solutions to those too, but they can also come at odd moments, unbeckoned, and give you ideas to solve problems you didn't think you had. And one great example is the philosopher and mathematician Descartes back in the, 17th century. He liked to lie in bed in the morning in a half-awake state and just sort of let his mind wander. And one morning he was there kind of half awake, half asleep, and he saw a fly buzzing around the room. And he thought, well, how can I mathematically describe the position in the room of that fly at any moment in time? And he had his aha moment. And that aha moment was, became analytic geometry. You have axes, X, Y, Z axes that are the walls and the ceiling and the floor of the room. And the distance of the fly from each of those gives the coordinates of the fly in space, which can be described mathematically. And even maybe perhaps better example that of a solution to a problem one didn't even know one has is the case of Richard James, who was an engineer aboard a U.S. Navy ship back in 1943 in the Philadelphia Naval Shipyards. And his job was to install instruments on springs that would be like shock absorbers, gauges and things, so that it would stabilize these instruments in turbulent seas so that they'd be easier to read. So he had these springs, he was installing gauges and things on the springs. And one of the springs got out of his hand and started bouncing around the room like it had a life of its own. And in that instant, he had this aha moment, which was, wow, this would make a great toy. So he refined it, he developed it, actually took him a couple of years, and it became the Slinky, which has been, I don't know how popular they are now, but when I was a kid, they were hugely popular. The spring, which can walk across the floor, go up or down the stairs. You can do all kinds of tricks with it. And Richard James was not looking to develop a toy, but he had in that moment what there's a professor at the MIT Sloan School of Business, he calls them need-solution pairs. The need or the problem and the solution occur to a person at the same time. So it's not like you have the problem first and then you come up with a solution. You come up with the problem and the solution simultaneously. So these aha moments can solve problems you didn't previously know you had. And that's not something that analytical thinking, this conscious, deliberate problem solving can usually do. That, the problem, you recognize the problem and then you work on it consciously. So that's one advantage. If you just want to sort of generate ideas without necessarily a goal, then you want to do things that will enhance insight and perhaps suppress analytical thinking. But if you're working on a very specific kind of problem that you have, then maybe analytical thinking might be the best approach until you're stuck. And if you're stuck, then maybe you want to wait for an insight or do something to enhance the likelihood of having an insight to break that impasse.
You're listening to The Science of Creativity, a podcast about art, design, and invention. If you're enjoying the episode, I hope you'll subscribe to the podcast and rate the show and leave a comment because it helps people like you find the show. You can find The Science of Creativity on all podcast platforms. So if you know what the problem is, then you can use that analytic mindset. But when you discover a new kind of problem, or I think it's called problem finding, when you find a problem that you didn't even know you had, and then you have an idea at the same time. So you discover the problem and you have the insight. And there's a lot of research showing that that will be a more breakthrough type of creativity.
Yes, exactly. And there have been a number of interesting scientific breakthroughs and ideas for in business for products and services like Richard James and the Slinky that have come from these sudden insights.
Right. I think there's a photo on your website, isn't there, of you playing with a Slinky?
Yes.
Right. I have one in my office. I love them. I think we must be the same age because I remember trying to get them to walk down the stairs.
Yeah. No, I could get it to walk down the stairs with some trouble when I was a kid. I was never good at getting it to go up the stairs. There is a way to do that, but
Right. And so I'm looking at titles of your journal articles, and you have a lot of articles in the media like the New York Times and Scientific American. You've been very good at getting the research out. And the titles often refer to different ways that you can enhance your ability to have these insights. There's one, actually, some of your articles are questions. I could just ask you the questions like, why do you get your best ideas in the shower was the title of an article in Time and New York Magazine. So yeah, why do you get your best ideas in the shower?
Clearly, we can't go into the shower and do experiments on people and test that. That would be, at best, strange. But we can make some very plausible inferences, educated guesses about that. So when you're in the shower, there are, for one thing, it feels good. You have a nice warm shower. It elevates your mood. In the shower, you have white noise, so you don't really hear much except the water. The water is roughly the same temperature as your skin, so you don't feel so much the boundary between the inside and outside of your body. Okay? And you can't see much. So it's sort of like not sensory deprivation, but shall we say sensory restriction. And usually people are not going to be bothered in the shower. I mean, people usually don't take their smartphones in the shower with them. So you have this pleasant feeling, elevated mood, some isolation. You don't fear that you're going to be interrupted or summoned while you're in the shower. And that puts you more in this sort of type 1, system 1 frame of mind. Your attention, your scope of thought expands. And I'm sure, many people, perhaps most people have experienced if you take a shower and you don't have some appointment you have to rush to or get to the office. Sometimes you can linger in the shower and it can go on because you sort of lose that feeling of time passing. And that kind of sensory restriction with low demand, low psychological threat, not very goal-oriented, promotes insights, promotes this sort of problem finding or idea generation mode. And I think, a lot of people have their own ways of doing that. There's a story that Thomas Edison used to sit in a chair with a steel ball in his hand and a pie tin on the floor. And he would allow himself to start to sort of fall asleep or get drowsy and to get into that hypnagogic state just before he would fall asleep. And if he fell asleep, the ball would fall out of his hand onto the pan and wake himself up. And then he would, like, what idea did I have at that moment? Okay. And it's interesting that Edison would do this because he was the one that claimed that, creativity or whatever is 99% perspiration and 1% inspiration. Well, he developed a very systematic procedure for having inspirations, for having these insights as well. So I forgot what your question was, but that's the answer.
It was the shower.
The shower, yes. So people have their own techniques, and it could be something, even just washing the dishes or gardening or walking the dog, anything that's sort of like low demand and pleasant and low sense of threat, and you don't have to do problem solving or whatever, that can get you partly into the state, but the shower certainly can do that. And also that period of time just before you fall asleep, or even during sleep, people have ideas that sometimes wake them up in the middle of the night. And those can be some great ideas as well.
Well, we're back to the Eureka Effect because that's a bathtub story, right? Archimedes in the bathtub.
Yes.
I guess you didn't have showers back in Greek times, but you had baths. So yeah, tell us that story.
Well, the story is that Archimedes, the great mathematician, physicist, engineer in, I guess it was about 3rd century BC. He was living in Sicily, which then mostly was ancient Greek colonies. And he was summoned by the king of Syracuse, King Hiero, who had a problem. And the problem was that Hiero had given a large amount of gold to a goldsmith to make him a crown. And the goldsmith made him a very nice crown. And the crowns in those days were not like the kinds of crowns we see in movies during the things that took place in medieval periods. The crowns in those days were like laurel leaves. They were very complicated, looked like wreaths, very complicated form and shape. So Hiero was concerned. He suspected that the goldsmith had actually included some baser metal in with the gold and pocketed the difference, saved some of the gold for himself. So he summoned Archimedes and said, you got to tell me, figure out, is this pure gold or is there a baser metal mixed in with it? Now, if Archimedes had been free to melt down the crown, then it would have been easy to do because he could have melted it down and poured it into the shape of a cube or a rectangle. And they knew, the formula for computing the volume of a regular shape like that, which would just be, the length times width times distance. But he knew the density of gold. So he would have been able to figure out, is this gold pure or not? Does it have the known density of gold? Because he could weigh it and he could compute the volume of it. But he wasn't allowed to do that. So he gave it thought, and one day he was stuck, and one day he poured a bath. He drew a bath for himself, and as he put his foot into the tub, he saw the water level rise, and then he realized he had this aha moment, this eureka moment, and actually, according to the story, he jumped up and ran down the street naked, yelling, "Eureka, Eureka," which in Greek means, "I found it, I found it." And what he realized in that moment was that he could measure the volume of any irregular shape by looking at how much water it displaced when the object was submerged in water. So if you have a container of a certain, say you have a 5-gallon container filled with water to the top, and you put that in a large tray, and you put the crown in it, well, the crown will displace water. The water will pour out over the sides of the container into the tray, and then you can pour that excess water into another measuring container to see how much volume it was, and that would tell you whether the exact volume of the crown, which combined with the weight of the crown, you could use to measure the density of the metal and determine that it was not gold. Now, historians doubt that this story actually happened in that way, because it was first appeared in, this was written down first 200 or 300 years, I think, after Archimedes lived. And in practicality, in practical circumstances, it would be very difficult to get a precise measurement of the density of the crown in that way. So historians kind of doubt. They think this was sort of mixing together two or three other things that really happened to Archimedes. But the story stuck. And the reason it stuck, it's a great story, and people resonate to it. They resonate to it because, for one thing, these aha moments are very dramatic. They're gripping. I mean, you look at at any like the TV series House MD. Almost every episode, he's stuck in his diagnosis, and he has this brilliant aha moment. And Hugh Laurie has cultivated all of these great ways of sort of expressing outwardly his inner aha moment when he solves the problem, comes up with the right diagnosis that saves the person's life. But also, this story stuck. It resonates with people because we've most of us have had these insights. Maybe not, these earth-shattering ones or life-changing ones, but we've had little ones, at least, that have solved real-world problems that make life easier, or at least that give people some enlightenment or this feeling of expansion of awareness that comes with having a new perspective on things.
And it sounds like something that, we'd all want more of, or some way to enhance that ability. And you've given us 2 suggestions, and one of them is to be in a positive mood. And the other one, I think, was to be, kind of like daydreaming, be in this kind of, if you'd say reverie state. So you've got 2 things. One is positive mood, and the other one is mind wandering.
Yes. Well, first of all, I should emphasize that insights, creativity in general is, I'd say, it's a strong spice. You don't want to use too much of it, right? You want to use it when it's appropriate, when it would be helpful, but you don't want to be necessarily generating new ideas all the time. I mean, sometimes you want to do things by the book, right? If you are having your appendix taken out, you want the surgeon to do it by the book. You want your airline pilot to do it by the book. On the other hand, if something goes wrong during the surgery or the plane is having a problem, then you want your surgeon or your pilot to be able to think creatively in the moment. And that might involve having an aha moment about how to save the day. But you don't want to necessarily destabilize things when, doing it by the book is known to work well, right? And people don't always, in the business world, people often don't trust leaders who are just trying to do new things all the time. It's like, what's this person trying to do? They're rocking the boat. Let's leave well enough alone. So it's a strong spice. You want to use it, but only at the right time, the right place, and to avoid trouble, right? Now, other ways to increase the likelihood of having aha moments. Well, one that, I don't recommend people use it, but I'm just reporting what's in the scientific literature. A little bit of alcohol does that. So a little bit of alcohol, not too much, because, if you drink too much, you can't solve any problems or have any good ideas. That is known to increase the likelihood of having insight solutions in various kinds of lab experiments. Time of day is an important factor. Some people are known to be morning people. They're at their sharpest in the morning. Others are sharpest at night. They're night owls. And when you're at your peak time of day, that's when you do your best analytical thinking. That's when your executive processes, when your frontal lobe is active and sharp and your attention is focused and your thinking is organized and deliberate. And that's when you do your best analytical thinking. But if you're an evening person, then you want to try to do your creative work in the morning when you're a little bit fuzzy. If you're a morning person, do your creative work at night when you're a little bit fuzzy. Anything that makes you a little bit fuzzy, not too much, just a little bit, like alcohol, like being your off-peak time of day, like being in a good mood, that's going to promote insights and it's going to squash analytical thinking. Another thing, and this is, I was going to say hot off the presses, but it's not published yet. We've submitted to a journal. We're waiting for feedback from the journal, is that people who have symptoms of ADHD, attention deficit hyperactivity disorder, tend to solve these puzzles an aha moment with a flash of insight. And people who are low in ADHD symptoms tend to solve them analytically. And one of the interesting things about this is that if you think of of ADHD as being sort of a continuum of strength of executive skills. The people who are lowest in ADHD symptoms, who have the strongest executive cognitive skills, are very good at solving these puzzles analytically. And people who are at the high end of ADHD symptoms are very good at solving these puzzles with insight as aha moments. But people in the middle actually solve fewer puzzles in our experiments. They're less good at solving puzzles either way than people on the ends of this continuum. So it's for certain types of problem solving, if you're going to have ADHD, it's better to have a lot of it or none of it. But being in the middle is not the sweet spot for certain types of problem solving. Now, not all types of problem solving, but at least the kinds we use, like these three-word compound remote associates problems that are often used to assess insightful, creative thinking. So those are other things. Sleep, getting a lot of sleep. Sleep has multiple benefits. One is that it puts you in a good mood, and being in a positive mood enhances insight. Another is that it promotes a process called memory consolidation, which reorganizes the information you have in memory, often to bring out remote associations and non-obvious ideas. And also, sleep is a way of doing what we call, what Stephen Smith at Texas A&M calls fixation forgetting, or sometimes forgetting fixation, which is if you're stuck on a problem and you're stuck on it because you're down an avenue of thought that is just not going to work, but you're stuck on that line of thought. You can take a break. If you take a break from that problem and you do something else that's non-demanding, you again walk the dog or wash the dishes or something like that, and then you come back to the problem, you're much more likely to solve the problem. Well, sleep supercharges this fixation forgetting situation. And so sleep flushes out, is very good at flushing out unproductive lines of thought. So that often if you're stuck on a problem and you take a nap or you just put the problem in your mind, then put it aside and sleep for the night, often in the morning, you look at the problem and go, well, this is obvious. It's easy how to do this. Very simple. And that's why often people, like people who are journalists, they're on a deadline. They have to get the story in by a certain time. They have to get a story in by, say, like 5 p.m. or something like that, or by midnight on a particular night. And they do the best they can, and they get the story in, and then they go to sleep. And then they wake up in the morning, oh no, I should have done it this way. Here's a much better way to do it. And because that sleep helped them to forget what they did a little bit. It loosens the grip on thought of non-optimal idea or a bad idea to allow a better idea to bubble up as an aha moment.
Right. But you might not even have that the next morning if you hadn't done that intense hard work the day before.
Absolutely. Absolutely. You can't. Well, I think for all forms of creativity, you have to do the hard work. If you don't have knowledge, then you for example, you can't win a Nobel Prize in physics if you haven't learned physics, done all the hard work to do that. Now, everybody is an expert at something, and it could be an expertise in just daily living. You're really good at what you have to do to thrive in your life. And you can have, because you're an expert at that, you've done the hard work, you've had the experience, the knowledge, the practice, you can have an aha moment, which can give you an even better way to do things. But you have to do the hard work. And that hard work could be on a specific problem, or you've just accumulated enough knowledge to start generating solutions to problems you didn't know you had by having an aha moment.
I think this might relate to another concept that I am really interested in, which is the flow state. And I've seen a lot of your recent articles, 24 and Things in Press in 25, that how do you get in this creative flow state? So How does all this relate to that? How would you describe that flow state, and how do you get into it?
Yeah, there's been a lot written about the flow state for, must be more than 50 years. It was first labeled and identified as such by Mihai Csikszentmihalyi, great psychological researcher, psychological scientist. And he and others have described it as a state of effortless attention, where you're working on something and you're absorbed in it, and it comes almost effortlessly, and it's very pleasurable, and you lose a sense of time and you become absorbed. Now, the early research on the flow state, a lot of that was on creativity, and then a later research focused on things like athletic performance and the like. The flow state, as I said, there's been a lot written about it, and a lot of it has been kind of contradictory or even fuzzy. There are a number of supposed criteria for what constitutes a flow state or how to get into a flow state. So, for example, one thing that's been proposed, which I don't really agree with, is the idea that when you have a task to perform and the difficulty of that task is matched to your level of skill, so it's not too hard and it's not too easy, then you can get into, or maybe by definition, you're even in a flow state. And one thing that led me to think that that's not a good way to think of things is what happened during the COVID pandemic. During the COVID pandemic, people were locked in at home, and there was a huge increase in sales of coloring books. And what people were doing was they were buying these coloring books, having them delivered by Amazon or whatever, and they would sit on their couch with crayons, and they would just start coloring in the pictures. And now, for an adult, that's not a demanding task. The skill level greatly exceeds the difficulty of the task. But people would get into this flow state, just, going through the coloring book, coloring in all the pictures. So that's an example where the skill does not have to be matched to the challenge or the difficulty. So I think we can put aside that particular technique for getting into flow or criterion or requirement for flow. I think just that everybody knows what being in the zone feels like in some task. And it's, again, that state of effortless attention where you're absorbed, but you're absorbed it's not that you're necessarily putting huge effort into it. It just seems to come to flow, to come very naturally and easily and with low effort, and time passes very quickly in that state. And my former graduate student, David Rosen, who's now a postdoc at Johns Hopkins University, as part of his doctoral dissertation research, he was interested in, and still is interested in, musical creativity. So his dissertation was not about flow specifically, but he included in his data collection a flow questionnaire to assess, so people could assess, his test subjects when they were in a flow state. And in this research, he had jazz guitarists improvising to set rhythm and chord sequences. And after these, they would do 6 improvisations, and they would report on they would fill out the flow questionnaire to describe to what extent they were in a flow state for each of these improvisations. And the improvisations were recorded and played back for expert judges who rated them for quality and creativity, etc. But we recorded EEG, electroencephalograms, while these musicians were recording their improvisations. So we could look at the brain processes associated with creativity and quality, but also flow. And we used musicians, jazz musicians, who ranged in expertise. Some of them were relative novices, and others were highly, highly experienced, who'd been performing professional gigs for decades and decades. And so, because we thought based on previous research that expertise, how much time you've put into this, the level of skill that you've acquired would be an important factor. And so one thing we found, the most obvious thing that hit us in the face, was that the expert musicians were reporting being in a flow state much more often than the relative novices. So there's something about expertise that seems to promote being in a flow state. And this makes sense because, if you're doing something you've never done before, you're not going to get into a flow state doing it. If it's the first time you've ever played tennis, you're not going to get into a flow state. If it's the first time you've ever played a musical instrument, you're not going to get into a flow state. Flow state comes, an enabling factor is experience, expertise, knowledge, skill, experience in doing a particular thing. The other thing we noticed is that when people were not in a flow state, they had more frontal lobe activity than when they were in a flow state. So this relates back to an idea that was put forth. I think he was the first person to use this term, transient hypofrontality. I think Arne Dietrich was. And the idea that when you're in a flow state, you have less frontal lobe activity. The frontal lobe is sort of the seat of these conscious, deliberate, executive processes. So that flow involves, in some sense, letting go of not micromanaging what you're doing. And what we found is that people who were not in a flow state when they were performing had a lot of frontal lobe activity, and people who were in a flow state had much lower frontal lobe activity. So the idea is that they were not, deliberately supervising, consciously manipulating what they were doing. So, for example, if you're consciously manipulating what you're doing, then you might be improvising and go, I'll try this. Oh, yeah, that worked well. I'll do some more of that, maybe a little bit different. Oh, now that's getting tired. I'll try something else. Oh, that didn't work well. I'll switch back to what I was doing before. That would be sort of deliberate thinking. That's not flow. But when you're in a flow state, and as our very experienced musicians reported, you just turn it on. You don't think about it. It just comes out. And that's what being in the flow state is. And the other thing we found is that the highly experienced musicians were not using the same brain areas during improvisation compared to the low experienced musicians. What we saw was the low experienced musicians were using mostly the left hemisphere as well as frontal lobe. And the high experienced musicians, less frontal lobe activity and more left hemisphere. So it's not right hemisphere creativity. In this case, it's sort of left hemisphere creativity. So the idea, and this goes back to a sadly neglected theory of creativity proposed by a neuropsychologist named Elkonin Goldberg. And he argues that when a task is relatively novel to you, then you're using mostly your right hemisphere. But through a great deal of experience and practice, that ability shifts to the left hemisphere and it becomes relatively automatic. So he notes, in support of this, he notes, for example, that when people have left hemisphere strokes, they're much more likely to have damage to their language ability compared to right hemisphere strokes. And as it turns out, adults are fluent at language, and their language is mostly in the left hemisphere. It becomes through years and years of practice in speaking, comprehending, reading, writing, etc. So the picture that seems to emerge from our flow research is that through a lot of experience, you can get into a flow state, and that involves developing a dedicated left hemisphere brain network that performs improvisation, in this case, musical improvisation, in a fairly unconscious, automatic way. And you have reduced executive processing, you reduced cognitive control, reduced deliberate thinking. So you're letting go. You have to, not choke. If you have anxiety, your deliberate thinking kicks in, you choke, and it suppresses that flow state. And then you switch to your right hemisphere deliberate thinking. So, but you have to do the work. You have to do the hard work. You have to acquire the experience, the training, acquire the knowledge as a prerequisite for being in a flow state in something, right? But as I said, everybody's an expert at something. And whatever you're already an expert in, you can achieve a flow state by letting go, reducing anxiety, letting go, just, taking a chance on doing things. And, but until you achieve that expertise, a flow state is going to be elusive.
Wow, that is really powerful. Thanks for that. And we're nearing the end of our time. I always like to end by asking for some practical advice for listeners. And you've already given us a lot of practical tips, but is there maybe an exercise or an activity, something people could do in the next week that might enhance their creativity?
I would say if the one single thing, if anyone could do one single thing to increase their creativity, is get more sleep. Right? Just get more sleep. And that helps creativity in many ways. But the other thing, the sort of the flip side of that, is to actually make some time for creativity. You're not going to be creative unless you make time to do it. If you don't make time to do it and then you complain, well, I'm not creative enough. Well, that, you have to actually give it a chance. If you don't give it a chance, and by give it a chance, I mean, put some time into it to actually practice creativity, as well as to acquire the knowledge and expertise to be, that is a prerequisite for being creative in any particular area.
Well, John, thank you so much for your time today. It's been a great conversation.
Oh, thank you. Thanks for inviting me.
My thanks to Dr. John Kounios for sharing the neuroscience behind insight and flow and creativity. If you enjoyed this episode, please subscribe to the show, leave a review, and share it with someone who loves great ideas. And as always, you can listen to every episode on YouTube and on all podcast platforms. Thank you for listening to The Science of Creativity. If you liked this episode, I hope you'll subscribe to the podcast, and please rate the show because that helps others like you hear about the show. Please write in the comments if you have requests or ideas for future episodes. I'll see you next time on The Science of Creativity for insights and inspiration about art, design, and invention.